Morning everyone. I've been asked a number of times if I could possibly make a video explaining how I make a crank axle for use in a locomotive that's got Stephenson link motion, which lots of them did. So here we go. I'll see what I can do for you. As you can see, I've got a series of components in front of me here. I've got a standard fine scale axle from Slater's. I have a pair of crank web and big end castings from Lorry Griffin. They're the right shape for the customer's locomotive. And I've got 4 eccentrics here. Now, I don't use the Lorry Griffin cast eccentrics because they don't fit the eccentric straps. They're always too big, and also they're cast, so they're never round, etc, etc. So I had a while ago, I had a local engineer machine a set of, a big bag of steel eccentrics that I always use in my Stephenson builds. A Lorry Griffin eccentric rod, the eccentric strap fits nicely around the eccentric sheave here, and it's quite a sloppy fit as well, which some of you engineering people out there might not like, but it means that the locos do run very freely, and I don't have to spend hours and hours and hours and hours and hours fettling them and tweaking them, which obviously costs the client a lot more money. So they are a fairly sloppy fit, but the payback for that is that they do work very quickly and they do work very smoothly without any tight spots. So that's where we've gone to there. So what I've done is I've fettled all these parts. They've all been cleaned up and polished, and the holes for the axles have been reamed to give a nice interference fit on the axles. So and I've done a basic calculation here. I've stacked up all the parts like that and measured them using my vernier, and the pile of components there, if you take that measurement, comes to 18.7 millimeters. Obviously a standard fine scale axle is 29.2 millimeters, which leaves 10.5, and if you divide that by 2, that you will then end up with 5.2 millimeters of axle protruding from the end of the of each crank casting on both sides. That's that calculation. The second thing you need to know is how to position the eccentrics themselves. If you were to use Lorry's method, there's like a little pin that locks, that goes through that hole there in the crank and locks all of the eccentrics in the correct position to each other. Obviously these aren't drilled, so what you need to do is look at a book that's something like that. This is a model locomotive valve gears book that I got years ago from a second-hand book, and you can see in it there's a chapter on Stephenson link valve gear. And that explains how the angle of advance works on the Stephenson type link motion. And I've drawn it out here. Basically, you have your crank and your crank pin, and if you can imagine a line through the eccentric like so, you'll see that they need to be fitted up with respect to the crank pin with that kind of angle. So in kind of like a Y shape, if you like that. And I find it easier when you're assembling the axle to just use a Sharpie and just kind of guess something like that, where the roughly where the centre line of these eccentrics lay, that there or something like that, and that allows you to kind of assemble them on the axle in approximately the right position. I mean, we're not looking for huge precision here. I mean, yes, of course, if you want to do it like that and you want to measure everything up, then you know, go ahead, be my guest. That'll help me when I come to assemble the axle, which we'll now go on to do. So these holes here have been reamed out such that they're an interference fit on the axle. If they're not an interference fit, it might be a good idea to just bruise up the edge of the crank web casting with a centre pop, just to kind of hold them fairly tightly on the axle. But I've got lucky here, and these are well, that's not such a good interference fit anymore. Now I've polished the axle a little. So what I'll do is I'll switch off for a moment while I just centre pop everything, and then we can assemble the axle together. Right, okay, what I've done is used my centre punch just to put a pop there and a pop there on the crank webs. So now they're a nice interference fit on the axle, which will hold them nicely in place while we're soldering. So I've positioned this on the axle. I've pushed it onto the axle, and I've set my verniers at 5.25 millimeters and popped the casting so that it's 5.25 millimeters away from the end of the axle. Also, what I've done is, if you look, you can see that I checked with the Slater's wheels, and the crank pin on the wheel face, if you can imagine, that's the square centre on the insert of a Slater's wheel. The crank pin's here in line with the point of the square here on the axle. Now you have to watch out, because sometimes they lie here on the flat, so you need to check that before you start positioning your castings on your axle prior to soldering. Okay, so we've got that in the right position. So if we take our first sheave and pop that on, and we're looking for this angle here for the centre of that one. You need to check with your drawing first to make sure that you're stacking them up in the right place, that the backwards and forwards rods will be on the right eccentrics, and so on and so on and so on. But that's something that you'll need to check with your drawing. I've pushed the second. This one's a bit more of a tight fit than the first one. We'll slide that along the axle slowly, carefully, so that we don't bump into the crank casting and move the position of it. And that, you can see, needs to be somewhere kind of in that orientation, so that it's at that angle. And then this is the hard bit. This is the kind of mental juggling part. That I know this locomotive's right-hand lead, so this crank, if you can imagine this, needs to be in that position, i.e. right-hand lead. So then we have to use a bit of mental agility here and work out where these two cranks need to be. They need to be in that orientation. So that one needs to go on. If we just draw ourselves a nice guideline on the bench, that one needs to be something like that. That one needs to be something like that, with the crank pin in that position. So we can now juggle that onto the axle in what we think's about the right position, which I think somewhere like that. We'll slide that on. There we go. And then this one, if we hold the crank pin like that horizontally to me, that one needs to go on something like that. So that's a bit of a looser fit, that one. So that's like that. And we turn this there, and don't disturb the position of the and the crank, the final crank, needs to go on the wheel, and that's quite a nice interference fit, like so. And now everything is orientated quite nicely. Check that that the crank pin on this is in line with the points, and we know all the eccentrics are in approximately the right position, so push everything together so nothing moves. Just check that. You see that's come out at 5.25, so we know that everything's now properly positioned on the axle and we're ready for soldering. So what I'm going to do is take this big screw, it's a BA screw, I'm not sure which it is, same as these Slater's nuts. Tighten that by hand onto the axle, check the final orientation and pop it into our vise ready for soldering. I'm going to turn you off while the soldering iron comes up to temperature, and then we'll solder this. Right, now we're up to stage 3 of the video where we are going to solder the axle up. I'm using a very large yet very cheap Antex soldering iron. It's a 100-watt soldering iron for those that are counting, and electrical solder, and I'm also using Baker's fluid flux, which we're going to need because of course we're soldering with steel. So I've put quite a lot of flux on there, and we'll load up the soldering iron tip with some electrical solder, and we will touch it on. And the secret here is to get quite a lot of heat into the job, and quite a lot of flux as well. And you'll see when the axle gets hot enough that the solder will start to flow. There it goes, quite nicely around the axle. And we're looking for that nice fillet of solder going all the way round the axle where the eccentric is, sorry, where the casting is. If you apply plenty of flux, you'll see the solder penetrating all the way through the joint. I'm going to check it in a minute that it's gone through underneath as well. And also you can see that the solder's started to penetrate into the 2 eccentric sheaves adjacent to it, so it looks like we've done that successfully. And equally we need to apply some flux to this, and then begin the soldering process with this big end. Stick a load of solder on there. You can see the solder's already starting to penetrate, and we're also putting a little bit of flux on the eccentrics as well to try and encourage the solder to flow between the eccentrics. A little bit more solder required there, and more Baker's fluid. It's quite smelly stuff, this. To just touch there to make sure that the first eccentric soldered to the edge of the crank web, and it is, I can see. And then I think we'll now touch here with a little bit of solder to make sure that the first and the second eccentrics are soldered together, and they are. There's a soldered joint. We'll clean all this up later. And then finally we'll touch here, and you can see the solder's already, the shiny solder's already appeared in that joint, so we're kind of home and dry now. We have done it. See, you can see what's happening. The flux is just allowing the solder to flood every area that we need, and that's good. So what I'm going to do now is allow this to cool down and just check that we've got full penetration with the solder all the way around, and it looks like we have. It looks like everything's good. So we're going to let that cool, and then move on to the next stage where we cut the axle in the crank webs. Right, this is now nicely cooled, and also I've been cleaned it, rinsed it with bicarbonate of soda solution. Basically I just put some powdered bicarbonate of soda in the palm of my hand and washed it with a brush. And this is quite important because baker's fluid's got some quite strong acids in it, and you need something to neutralise them so that it doesn't start to corrode the components. So bicarb's a nice sort of mild base which will neutralise all the acids. You can actually see the bubbles taking place as the reaction occurs between the bicarb and the workpiece here. It's quite a good idea to do that on all soldering jobs. You know, if you're building a commercial kit, for instance, it will neutralise the acid in between soldering sessions and stop your model getting corroded, turning green or white, flaky colour or whatever. Right, I'm going to cut through the webs now. So what I'm doing is popping some safe jaws in my vise, like so I don't bruise the axle when I tighten the vise up. They're just some little bits of brass that I've fashioned with a hammer. Right, so there's the workpiece in the vise, and I'm going to get my favourite saw, which in my case is my trusty piercing saw. I mean, you can use any saw you're happy with. And I'm going to make some cuts there through the axle to take this centrepiece of axle out from between the crank webs and finish off the basic job. Everything's nicely soldered to everything else, but even so, I'm holding it here, and I'm going to make the first cut there and the second cut here so that I don't put too much stress on this joint. I know that some of you, when you're building a crank axle, like to pin them first. I never bother because I've never had a failure using this method, but if you want to go down the belt and braces route, feel free. Right, I'm going to turn you off while I do the cutting, because you're not going to want to sit there with your cup of tea watching me cut through, make 3 cuts like this, and I'll bring you back when we do the final finishing. Right, the final stage of this now is the cleaning up. You can see that I've cut the axle out in between the crank web to complete the basic structure. It's quite a satisfying thing when the little pieces of axle drop onto your floor. Chuck those over there in the bin. The next thing we're going to do is just clean up all the excess solder and clean up the axle ends inside between the crank webs. And we're going to do that using just a slitting disc in a mini drill. And quite simply, you just go in and very gently and very carefully grind out the bit of the axle there that's left over in between the crank webs until it's all nice and smooth, so that nothing's going to catch, the rods aren't going to catch on any burrs that are left in there, and everything will, you know, it'll enable your loco to run really smoothly. And if you hold the workpiece in your hand, there's no chance of the grinding action getting the thing too hot and the soldering that you've just done melting. I never use silver solder. I've never really seen the need. Electrical solder seems to work perfectly for me. So that's one done, nice and smooth. And I'm going to crack on now and do the others. And then when I've finished doing that with the grinder, then I'm going to go in with a sanding disc and just get all the excess solder off all the other surfaces and polish them up and make it look beautiful. And I'll bring you back in a while when I've done that. Right, So here we are, the final finished axle. It's all been sanded down and polished and everything. I'm afraid there's no secret to this other than just good old elbow grease. So all the material's been smoothed on the inside between the crank webs so that it won't clout into your conrod, and all of the surfaces of the eccentrics have all been cleaned and polished, all the excess solder removed, and that's ready to go. So I'm going to go outside now and squirt it with some carb cleaner to get all the residue off it, and then I'm going to squirt it with some WD-40 to stop it rusting while it's sat waiting to be used. Thank you very much. Hope that was useful.